Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 25 Probability. We have already studied the concepts and solved questions from Exercise 25A. Today, we will be discussing this in detail and solve questions from Exercise 25B. Hope you all are ready with your pen and papers. Let's solve together. Let us take an example. Example 1. 3 identical coins are tossed together. What is the probability of obtaining? First, all heads, then exactly 2 heads, exactly 1 head, at least 1 head, at least 2 heads, all tail. When 3 coins are taken. So here, with the coin, you will be having 2 outcomes, head and tail. Okay. We will be having 2 raised to n outcomes when it is 1 coin, 2 raised to 1. 2 coins, 2 raised to 2. 3 coins, 2 raised to 3. Here it is 3 coins. Therefore, you will be having 2 raised to 3 which is equal to 8 outcomes. Now, what are the 8 outcomes? When head comes first, you will be having 4 outcomes. When tail comes first, you will be having 4 outcomes. So, write like this: 4 head, 4 tail. For the second coin, head, head, tail, tail, head, head, tail, tail. This is how you will be making a combination. Okay. Next, third coin, head, tail, head, tail, head, tail, head, tail. So, these are the 8 outcomes possible. Now, check this outcomes. Here, the first is head, head, head. All are head. Last one, tail, tail, tail. All are tail. Then what we have? We have cases of 2 heads. We have cases of 2 tails. We have cases of 1 tail. We have cases of 1 head. But here, what does at least 1 head means? At least 1 head means it can be 1 head, 2 head or 3 head. All the cases can be included. It cannot include tail, tail, tail. All other outcomes can be included. Okay. What about exactly 1 head? It is a case with only 1 head present. Okay. Only 1 head. Now, let us fill this table. We have to find the probability of obtaining all these. First, we have all heads. What is the total number of outcomes? N of S. N of S is equal to 8 outcomes. Okay. Number of outcomes favorable. Favorable outcomes in case of all heads. All heads. How many outcomes have all heads? Just 1, right? Head, head, head. This is the thing. So, 1. Which is head, head, head. Okay. Then what is the probability? Tell me, what is probability? Probability is N of E, number of outcomes favorable divided by total number of outcomes. N of E divided by N of S. Probability is N of E divided by N of S. Here N of E is equal to 1 and N of S is equal to 8. Therefore, the probability is 1 by 8. When all heads, the probability is 1 by 8. 1 out of all the 8 outcomes. Okay. Next is exactly 2 heads. 2 times H should come. Okay. What are the cases? Can we take H, H, H? No, right? Because here it is exactly 3 heads. Exactly 2 head means only 2 times head can appear. Okay. This case can be taken H, H, T. H, H, T can be taken. Then H, T, H can be taken. H, T, H. Then, what else? H, T, T. Can you take this? No, right? Here, 2 tails are appearing. T, H, H. Exactly 2 heads. T, H, H can be taken. Any other? No, right? We are getting 3 favorable outcomes. So, what is the probability in this case? Here, the probability will be equal to 3 divided by 8. Next, exactly 1 head. Exactly 1 head means only 1 time head should appear. Okay. This is not possible. This is not possible. This is not possible. We can take H, T, T. Okay. H, T, T. Then, T, H, T can be taken. T, H, T. Only 1 time head is appearing. Then, T, T, H can be taken. T, T, H. 3 outcomes. Okay. Therefore, the probability is 3 divided by 8. Next, at least one head. At least one head. As I said, it can be 1 head, 2 head or 3 head. Okay. Therefore, what are the cases? Head, head, head can be taken. Head, head, tail can be taken. Head, tail, head can be taken. Head, tail, tail can be taken. Tail, head, head can be taken. Tail, head, tail can be taken. Tail, tail, head can be taken. Can you take tail, tail, tail? At least one head. Here there is no heads at all. Okay. So what are the total number of favorable outcomes? 1, 2, 3, 4, 5, 6, 7. 7 outcomes are favorable. Here the probability will be 7 divided by 8. Okay. 7 by 8 is a probability. At least 2 heads. Now tell me, at least 2 heads. What are the cases? At least 2 heads means 2 heads or 3 heads can be included. So H comes here. Then HT can be taken. HTH can be taken. HTT, can you take this? No, right? There is only one head. THH can be taken. THT cannot be taken. TTH also cannot be taken. TTT also cannot be taken. So 1, 2, 3, 4. 4 outcomes are favorable. Therefore, you will be getting 4 divided by 8. Reducing to the smallest ratio, you get 1 by 2. Okay, 1 by 2 is the probability. All tails, just one case. TTT. Just one case is there. There the probability will be 1 by 8. Clear? This is how you will be doing. So understand what at least means, exactly means. Now what about at most? What does at most mean? Maximum this much. At most 1 head or at most 2 head means either it can be 1 head or 2 head. It cannot be 3 heads. Okay. Let us now solve problems from exercise 25B. Here we have the first problem. Question 1 of exercise 25B. 9 cards identical in all respects are numbered 2 to 10. A card is selected from them at random. Find the probability that the card selected will be the first one, an even number, second, a multiple of 3, third, an even number and a multiple of 3, fourth, an even number or a multiple of 3. Okay. So here what is the sample space? We have cards numbered from 2 to 10. There are 9 cards. Okay. 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the 9 cards. What is the total number of outcomes N of S? N of S will be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Already it is given 9 cards. Okay. Now the first one, here the event is getting an even number. Okay. What are the even numbers that are present in the sample space? 2 is an even number. 4 is an even number. 6 is even. 8 is even. 10 is even. So these are the even numbers. Okay. Then number of outcomes favorable to the event. Here the event is choosing an even number. Okay. Number of outcomes favorable to the event. 1, 2, 3, 4, 5. Okay. N of E is equal to 5. Then what is the probability of the event? Number of outcomes favorable to the event divided by total number of outcomes, which is 5 divided by 9. So the answer for the first question is 5 by 9. Now the second one. A multiple of 3. Here the event is multiple of 3. Multiple of 3. Okay. 3 is a multiple. 3 ones are 3. 3 twos are 6. 3 threes are 9. Okay. So these 3 can be included. 3, 6, 9. Okay. Then what is the number of outcomes favorable to the event? 1, 2, 3. We have 3 outcomes favorable to the event. Okay. We got n of e is equal to 3. Then the probability of the event will be equal to number of outcomes favorable to the event divided by total number of outcomes, which is 3 by 9 can be cancelled to 1 by 3. 3 by 9 can be reduced to 1 by 3. 3 ones are 3, 3 threes are 9. Okay. Now the third one, an even number and a multiple of 3. 2 conditions are there. In both these cases, just one condition. It should be an even number. Second one, it should be a multiple of 3. Here, both the conditions are coming together. That is, it should be an even number and should be a multiple of 3. Okay, which are the even numbers? 2 is an even number, but it is not a multiple of 3. 4 is an even number, not a multiple of 3. 6 is an even number and is also a multiple of 3. Therefore, 6 can be included. Okay, next even number is 8. 8 is an even number, but it is not a multiple of 3. 10 is an even number, again not a multiple of 3. So there is only one outcome that is favorable, which is 6. Okay, number of outcomes favorable to the event is equal to 1. Probability of the event will be equal to number of outcomes favorable divided by total number of outcomes, which is 1 divided by 9. Okay, 1 by 9 is your probability. Next, the fourth one. An even number or a multiple of 3. Here, the word is and here it is or. Okay, and means both the conditions should be satisfied. Or means either of the 2 conditions. It can be both the conditions satisfied or at least one condition should be satisfied. Okay, either it should be an even number or it should be a multiple of 3. It can even be an even number which is a multiple of 3. So, here the event includes 2 is an even number, then 4 is an even number, 6, 8, 10. These are the even numbers. Now, next the multiples of 3. Multiples of 3 also can be included here. 3, then 6, and 9. Now remember one thing, here 6 is repeating 2 times, which means 6 is an even number and is also a multiple of 3. So don't put 6 2 times, just put 6 one time. Okay. Therefore, the number of events favorable will be 1, 2, 3, 4, 5, 6, 7. N of E is 7. Then the probability of the event will be N of E divided by N of S, which is equal to 7 by 9. The final answer is 7 by 9. 7 by 9 is the probability. Clear? Let's move on to the second problem. Question 3 of exercise 25B. From 25 identical cards numbered 1 to 25, one card is drawn at random. Find the probability that the number on the card drawn is a multiple of first 3, then 5, 3 and 5, 3 or 5. Okay. So, the sample space will include numbers from 1, it can be 2, 3, 4, 5, etc. up to 25. Okay. So, what is the total number of outcomes? N of S. It can be 1, it can be 2, it can be 3, up to 25, any number it can be. Therefore, there are 25 cards. N of S will be equal to 25. Now, take the first one. Here, the event is multiple of 3. Okay. 3 ones are 3. So, 3 can be included. Then 6 can be included. 9 can be included. 12, 15, 18, 21, 24. Can I put 27? No, right? Why? Only cards numbered up to 25 is available. So, up to 24 can be taken. 24 is also a multiple of 3. 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, 3 fives are 15, 3 six are 18, 3 sevens are 21 and 3 eights are 24. So, these are the required outcomes favorable. Number of outcomes favorable to the event will be equal to 1, 2, 3, 4, 5, 6, 7, 8. 8 outcomes are favorable to the event. Then the probability of the event happening will be equal to number of outcomes favorable divided by total number of outcomes, which is 8 by 25. Can we cancel this? No, right? There is no common factor. Therefore, 8 by 25 is your answer. Next, the second one. Here the event is multiple of 5. Multiple of 5. It includes 5, then 10, 15, 20 and 25. Can I include 30? No, we have only cards up to 25, numbered up to 25. So what is N of E? Number of outcomes which are multiple of 5. 1, 2, 3, 4, 5. N of E is equal to 5. Then the probability of event will be N of E by N of S, that is 5 divided by 25. Here we can cancel 5 5s are 25. Therefore 1 by 5 is your answer. 1 by 5 is the probability of taking a card which is a multiple of 5. Next, the third one, 3 and 5. This is the event. Multiple of 3 and 5. Okay. And 5. Remember here, this is and. It should be the multiple of both 3 and 5. Okay. We know the multiples of 3. 3, 6, 9. Here you have to check if it is the multiple of 5 as well. Is there any number which is the multiple of both 3 and 5? Here we have 15. Here also we have 15. Is there any other number which is common? No, right? So 15 is a number. It is a multiple of 3. 3 5s are 15. And 5 3s are is also 15. Okay. So it is both the multiple of 3 and multiple of 5. Okay. Therefore, you can have only one outcome favorable, which is 15. Number of outcomes favorable to the event is equal to 1. Total number of outcomes we have 25. Therefore, the probability of event will be equal to number of outcomes favorable divided by total number of outcomes 1 by 25. Clear? 1 by 25. Next is the fourth one. Here it is or. The third one it is and. Or means either it should be multiple of 3 or it should be multiple of 5. Or it can be multiple of both 3 and 5. At least one of these two numbers, that is 3 and 5 selected. It should be the multiple of any of these two numbers. So the event is 3 or 5 includes. First take the multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24. Now take the multiples of 5, 5, 10. 15 is already included. 20, 25. Okay. Counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here the number of outcomes favorable to the event is equal to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Now the probability of the event will be equal to number of events favorable divided by total number of outcomes. 12 by 25. Again, it cannot be cancelled. There is no common factor. 12 by 25 is your final answer. Got it? Next, problem number 3, question 5 of exercise 25B. A book contains 85 pages. A page is chosen at random. What is the probability that the sum of the digits on the page is 8? Here, there are 85 pages. So, the sample space will include page number 1, page 2, page 3, page 4, etc. up to page 85. Okay, this is a sample space. Now, the total number of outcomes. What is the total number of outcomes? There are 85 pages. Total number of outcomes will be equal to 85. Okay. Now, we need the event. The event is the sum of the digits on the page number will be equal to 8. How to take? For example, if you select page number 27. What is the sum of the digits? 2 and 7 are the digits. Sum of digits 2 plus 7 will be equal to 9. Okay. We need to get 8. How do we get? For example, take page number 8. Okay. 0, 8. 0 plus 8 is equal to 8. Next, page number 17. 1 plus 7 is 8. Page 26. 2 plus 6 is 8. Page 35. 3 plus 5 is 8. Page 44. 4 plus 4 is 8. Page 53. 5 plus 3 is 8. 62. 6 plus 2 is 8. 71. 7 plus 1 is 8. 80. 8 plus 0. That is 8. Okay. So the event includes the pages. Page number 8. Page number 17. Page 26. 35. 44. 53. 62. 71. And 80. Okay. Number of outcomes favorable to the event is equal to, count, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 events are favorable. N of E is equal to 9. Okay. Now we can easily find the probability. P of E will be equal to number of outcomes favorable to the event divided by total number of outcomes, which is equal to 9 divided by 85. Okay, 9 by 85 is your answer. It is the probability of selecting a page which has the sum of the digits on it equal to 8 is equal to 9 by 85. Clear? Next, problem number 4, question 6 of exercise 25B. A pair of dice is thrown. Find the probability of getting a sum of 10 or more if 5 appears on the first die. So when we have 2 dice here, okay, pair of dice, there are 2 dice. So it can be like when you throw it randomly, one can appear on the first die and the same one can appear on the second die. So this is one chance. 1 is on the first die and 2 is on the second die. This is another chance. 1 on first die, 3 on the second die. 1 first die, 4 on the second die. Then 1 on the first die and 5 on the second die. 1 on the first die, 6 on the second die. So there are 6 cases when 1 appears on the first die and all other digits appears on the second die. 1, 2, 3, 4, 5, 6. Any of the digit appears on the second die. You got 6. Okay. Similarly, when you take 2 on the first die, you will be having 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. All these are possible. 2 on first die, 1 on second die. 2 on first die, 2 on second die. Now when you take 3, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6 are the 6 chances. When you have 4, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Next 5, 1, 5, 2, 5, 3, 5, 4, 5, 5 and 5, 6. Okay, 5 on the first die and on the second die you are getting 1, 2, 3, 4, 5, 6, anything. Okay, now 6 on the first die, 1 on the second die, 6 on first, 2 on second, 6, 3, 6, 4, 6, 5, 6, 6. Okay, so this is the sample space. Okay, this is your sample space. Total number of outcomes. What is the total number of outcomes? Count. Here with 1 on the first die you are getting 6. 2 on the first die again 6. 3, 6. 4 on the first die 6. 5 on the first die 6. 6 on the first die 6. So on adding 6 plus 6 plus 6 plus 6 plus 6 plus 6 you will be getting 36. So the total number of outcomes is equal to 36. Now come to our event. Here what is the event? Getting a sum of 10. Now take the sum. Here 1 plus 1, it is 2. It is not 10. You should get the sum should be 10 or more than that, greater than 10. Okay. The sum should be either equal to 10 or more. Okay. And one more thing, 5 appears on the first die. The condition is 5 should appear on the first die. Okay. 5 and 1. When you take 5 and 1, it is 6. Not possible. 5 and 2, it is 7. 5 and 3, 8. 5 and 4 is 9. 5 and 5 can be taken because 5 plus 5 is 10. So one chance is getting 5 on the first die and same 5 on the second die. Then 10 or more. Okay, when you take 5 and 6, 5 plus 6 is equal to 11. So that can also be chosen. It is a number greater than 10. So we have just two options. We cannot take all of these. When 6 comes, you can take 6 plus 4 is 10. But you need to get 5 on the first die. Okay, the number of events, number of outcomes favorable to the event will be equal to 2. Then what is the probability of the event? N of E divided by N of S, that is equal to 2 by 36, 1 by 18. 1 by 18 is your probability. Clear? Problem 5, question 9 of exercise 25B. A card is drawn from a well-shuffled pack of 52 cards. Find the probability that the card drawn is first a spade, a red card, a face card, 5 of heart or diamond, jack or queen, ace and king, a red and a king, a red or a king. Okay. So first we have 52 cards, which means the total number of outcomes is equal to 52. Now the first case, the event is a spade. How many spade cards do we have? There are 13 spade cards. Okay. Therefore, here the event is getting a spade card. Number of outcomes favorable to the event will be equal to 13. We have 13 spade, 13 club, 13 hearts and 13 diamonds. N of E is equal to 13. Then what is the probability? Probability of the event will be equal to number of outcomes favorable to the event divided by total number of outcomes, 13 by 52. 13 into 4 is 52. Therefore, 1 by 4 is your answer. Okay. Now the second one, a red card. The event is getting a red card. How many red cards do we have? We know that in a deck of cards, in a deck of 52 cards, half of the cards will be red cards and half will be black cards. Okay, so we will be having 26. 52 divided by 2 is 26. 26 cards will be red in color. N of E is equal to 26. Then the probability of the event will be equal to number of outcomes favorable to the event divided by total number of outcomes. 26 by 52, which is 1 by 2. Okay. Now the third one, a face card. The event is getting a face card. How many face cards do we have? Yeah. Which are the face cards? Jack, queen and king. Okay. So jack of diamonds, queen of diamonds, king of diamonds. Then jack of hearts, queen of hearts, king of hearts. Jack of spade, queen of spade, king of spade, jack of club, queen of club, king of clubs. Okay. So how many cards, how many face cards you are having? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 face cards you are having. So here, number of outcomes favorable to the event will be equal to 12. And hence the probability of the event will be number of outcomes favorable to the event divided by total number of outcomes, 12 by 52. 12 by 52. 4 3s are 12. 4 13s are 52. Okay, so your answer is 3 by 13. Next, the fourth one, 5 of heart or diamond. Okay, 5 heart or 5 diamond. In a deck of 52 cards, you will be having a 4 5 cards will be there. Yes, in this 4 5 cards, 1 5 card will be heart, 1 5 card will be diamond, 1 will be spade, and the other will be the club. So of this 4 cards, either you should be having a heart or a diamond 5. 5 of heart or diamond. Okay, so just 2 cards are there. Here, number of outcomes favorable to the event is equal to 2. Probability of the event will be n of e divided by n of s, which is 2 by 52 equal to 1 by 26. Okay, 1 by 26. Next one. Fifth one. Fifth one is jack or queen. How many jack cards do we have? We have 4 jack cards. Diamond, heart, spade and club. Queen cards 1, 2, 3, 4. 4 again. So either it should be a jack or a queen. 8 options available. So here number of outcomes favorable to the event will be equal to 8. Then the probability of the event is equal to n of e divided by n of s. That is 8 by 52. On cancelling, we get 4 2s are 8, 4 13s are 52. 2 by 13. Two by 13 is your answer. Next, the sixth one. Ace and a king. Ace is the A, the card with A written on it. Can we have ace and king on the same card? No, right? We cannot get a card which is having ace and king written on it. Which means here there is no outcome which is favorable to it. N of E will be 0. If it is ace or king, then it is okay. Ace cards and king cards can be included. But remember, here it is and. Difference between and or you should know. Okay. When it is and, both these conditions should be satisfied. It is compulsory. Therefore, we will be getting n of E is equal to 0 and hence the probability of the event will be n of E by n of S equal to 0 by 52 equal to 0. We will be getting 0. There is no event that will be favorable to this condition, ace and king. So the seventh one, a red and a king. Both these conditions should be satisfied because here we have and. It should be a red card and a king. Okay. Red cards, we know these are the red cards. Okay. So in the case of king, you should get red cards. That is king of diamond and king of hearts are the two options possible. King of diamond and king of hearts. Okay. So you will be having king of diamonds and king of hearts. Therefore, the number of outcomes favorable will be equal to 2. Total number of outcomes is 52. Probability of event will be 2 by 52 equal to 1 by 26. Next is a red or a king. Red or a king is the event. Okay. Red or king. All the red cards can be included, which means all the 26 can be included. Then black king cards can also be included in this. Okay. Red color king cards, that is red king cards are already included. You can also include the black king cards. So these are black king cards. Yes. That is a spade and club can be included. 2 more cards. That is 26 plus 2, which is 28. Number of outcomes favorable to the event will be 28. Probability of the event will be n of E divided by n of S equal to 28 by 52. Seven into 4 is 28. 13 into 4 is 52. 7 by 13. 7 by 13 is your answer. Clear? This is it. Next, problem number 6, question 10 of exercise 25B. A bag contains 16 colored balls. 6 are green colored, 7 are red and 3 are white. A ball is chosen without looking into the bag. Find the probability that the ball chosen is. Here again you have 7 sub-questions: red, not red, white, not white, green or red, white or green, green or red or white. Okay, here the sample space will include all these green balls, all these red balls and all these white balls. That is the total balls, total colored balls. Sample space will include all these. Therefore, the total number of outcomes will be equal to all the 16 balls. Okay, now take the first case. So here we are having 6 green balls, 7 red balls and 3 white balls. The first event is, it should be a red ball. Okay. How many red balls do we have? We have 7 red balls. So N of E will be equal to, that is, the number of outcomes favorable to the event will be equal to 7. Clear? Then what is the probability of the event? Probability of the event will be equal to number of outcomes favorable to event divided by total number of outcomes, which is 7 divided by 16. Now the second one, it is event is not red. Not red. It should not be red. If it is not red, it can either be green or it can be white. So both these can be included. You have to just eliminate the red balls. That is, take away all the red balls, and from these two options, that is green and white, you can choose the balls. Then how many will be there? What is N of E? N of E will include both the green balls and white balls. We have 6 green balls and 3 white balls. 6 plus 3, 9. Okay, N of E will be 9. Then the probability of the event will be equal to N of E divided by N of S, 9 by 16. Okay. Next, the third one, white balls. Very easy, right? We have just 3 white balls. Therefore, number of outcomes favorable to the event is 3. Probability of the event will be equal to number of outcomes favorable to event divided by total number of outcomes, 3 by 16. Fourth one, not white. Event is the ball being not white. Not white means either it can be green or it can be red. Here we have 6 green balls and 7 red balls. 7 plus 6 is equal to 13. Therefore, number of outcomes favorable to the event, that is the ball being not white, is equal to 13. Probability of the event will be number of outcomes favorable to the event divided by total number of outcomes, 13 divided by 16. Okay. Next, the fifth one, green or red. Green or red is a event, which means except white, you can either take green or you can take red. The same answer you will be getting. Here the event is green or red. Green or red and not white. Both means the same thing. So here N of E is equal to 6 plus 7, which is 13. And the probability of the event will be N of E divided by N of S. That is 13 by 16. Okay, so the next one, sixth one, white or green. White or green. We have 3 white balls and 6 green balls, which means it cannot be red, it can be green or white. Okay, so the not red. Not red, what do we get? The same thing here also we get. So number of outcomes favorable to the event includes 3 plus 6, which is 9. N of E is equal to 9 and the probability of the event is N of E divided by N of S equal to 9 by. Next, the final one, that is 7th, green or red or white. It can either be red, it can either be green or it can be white, which means all the balls can be included. N of E will be equal to 6 plus 7, 13 plus 3, 16. Therefore, the probability of the event will be equal to N of E divided by N of S. N of E is also 16. N of S is also 16, which means answer is 1. Okay. Got it? Problem 7, question 11 of exercise 25B. A ball is drawn at random from a box containing 12 whites, 16 red and 20 green balls. Determine the probability that the ball drawn is first option white, second red, third not green, fourth red or white. Same as the question that we have solved just before. Here we have 12 white balls, 16 red balls and 20 green balls. What is the total number of balls? Total number of balls is the total outcome will be equal to 12 plus 16, 28, 28 plus 20, 48. Okay. The first one, it should be a white ball. Event is the ball chosen being a white ball. How many white balls do we have? We have 12 white balls. N of E will be equal to 12. Then the probability of event will be N of E by N of S equal to 12 by 48. 4 into 12 is 48, therefore 1 by 4. Okay. Now the second one, it is a red ball. The event is getting a red ball. How many red balls we have? We have 16 red balls, which means N of E is equal to 16. And hence the probability of event equal to N of E divided by N of S, which is 16 divided by 48. 16 into 3 is 48. Therefore, 1 by 3. Next, the third one, not green. The event is getting a ball which is not green in color. Not green means either it should be white or it should be red. We have 12 white balls and 16 red balls. Therefore, the number of outcomes favorable to the event will be 12 plus 16. 12 plus 16, which is equal to 28. Okay. Therefore, the probability of the event will be equal to N of E divided by N of S, that is 28 by 48. Okay. 4 into 7. 4 into 7 is 28. 4 into 12 is 48. 7 by 12 you will be getting. Next, the fourth one, red or white. Okay. The event is getting a ball which is red or white in color. Red or white. That is, you should not take green balls. You can take only white balls or red balls. Same thing. N of E will be equal to. Not green means it should be either red or white. Again 28. 12 plus 16 equal to 28. Then the probability of the event will be N of E by N of S. That is 28 by 48, which is equal to 7 by 12. Again we are getting 7 by 12. Okay. Understood this problem? Okay, fine. Here we have the last problem for today. Problem number 8, question 13 of exercise 25B. 30 identical cards are marked with numbers 1 to 30. If one card is drawn at random, find the probability that it is a multiple of 4 or 6, then a multiple of 3 and 5, a multiple of 3 or 5. Okay, here the sample space will include card with number 1, 2, 3, 4, etc. up to 30, which means the total number of outcomes will be 30. Now, what is the first one? Here the event is a multiple of 4 or 6. Multiple of 4 or 6. Multiples of 4 are 4, 8, 12, 16, 20, 24, 28. Up to 30 only we have. We cannot take 32 then. Up to 28 you will be having. Or 6, which means multiples of 6 can also be included. 6, then comes 12. 12 was already taken because it is also a multiple of 4. Then 18. Then you have 24. 24 is also included here. Okay. Then you will be having 30. So these are the possible outcomes. What is n of e in this case? N of e is equal to counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, n of e is equal to 10. Probability of this event will be equal to number of outcomes favorable to event divided by total number of outcomes. 10 by 30 equal to 1 by 3. Clear? Next, the second one, a multiple of 3 and 5. Here it is and. It should be the multiple of 3 and the multiple of 5. Okay. Multiples of 3. We know the multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Okay. Within 30, up to 30, you will be having these are the required multiples. Next, the multiple of 5. 5, 10, 15, 20, 25, 30. So here what is the condition? It should be the multiple of both 3 and 5. Common in both these. Consider both these, the numbers which are common to both. Which are the numbers here? You can find 15 in both. Then you can find 30 in both. Okay. So these two are the numbers which are both multiple of 3 and multiple of 5. So you have 15 and 30. Number of outcomes favorable to the event is 2. And hence the probability of the event will be n of e by n of s equal to 2 by 30, 1 by 15. Okay, 1 by 15 is a reduced ratio. Now the third one, a multiple of 3 or 5. It can be multiple of 3 or it can be multiple of 5 or multiple of both 3 and 5 can also be included here. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, all these can be included. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Then the multiple of 5 can also be included. 5, 10, 15 is already taken. 20, 25, 30 is also already taken. Now counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have 14 outcomes favorable to the event. Then the total number of outcomes here is equal to 30. Probability of event will be equal to n of e by n of s, which is 14 by 30, 7 by 15. So 7 by 15 is your answer. Got it? So this is it. So remember, when you have and when you have or, both are different. Okay? And means both should be included, or means at least one should be included. Clear? That's all for today. In today's class, we have discussed about probability with examples and solved questions from exercise 25B. Hope you all enjoyed. There are a few more questions left. You can solve it on your own. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai par best hai. Thank you.